And good morning. Happy Saturday. Gonna hop into it today. Let's see what we find. Getting knee deep in some shaders. And we really can't swim very well in shader water, so we'll see how it goes again. Getting better though. Getting better, and that's what's important. To the shaders. To the shaders. There we go. All right. So we have our power set to 0. If we set our power to, say, 1, it glows. Right. Boom. So our goal is based on the quadrant and the value inside the quadrant to make our gap move around and based on the time. All right, let's work on what would happen if the quadrant was just the first quadrant. And that's less than or equal to 1. Is that correct? Let's make that 0, 1, 2, and 3. Starts out as 0. Here we'll just say power is equal to 1.0. No, it's equal to, let's say, 0.25. Morning, Zenacron. How's it going? Oh, interesting. What? What? Oh, that's messed up. Less than or equal to zero point 0.5. You decided to experiment a bit with NVim LSP, and you can confidently say that the only thing worse than writing Vim script or Lua is having to write both at the same time. Oh, that's fantastic. I concur. Else if else equals 2.0. How's it going? I just discovered that the UVs aren't correct. It looks like we're all come on. I don't have Vim here. Wow. Only these sections got set up for UV. What if we set this to oh that's UV dot Y. Yeah, that should be UV dot Y, but why are only those sections colored? On the bright side, the diagnostics panel stays open instead of auto-closing. That does look weird, doesn't it? Oh, you know what? I didn't actually build this and then run it. I guess I did build it, but I didn't run it because I changed the values. I guess I should change the big comment too. That's more accurate. Okay, that doesn't look bad. So we're just trying to highlight the first quadrant. Interesting, the little Z tearing here. No, that's not Z tearing. That's just, what is that? Hmm. Oh, fascinating. So some stuff over here got the same UV. What? This one got none. Less than or equal to. Oh, well, that kind of makes sense, right? Because it's less than or equal to a specific value. Let's say it must be equal to 0. Let's see how that works out. Because the UV is a gradient. That's right. It gets sampled just like UV.x. I forgot about that. All right, so if it's from, oh goodness, if it's less than 0.5, we do this. If it's greater than 0.5, so this was going to be 0. This is going to be 0.25, just for fun. Else if uv.y, actually we could just set the power to the UV at the moment and see what it looks like. uv.y divided by 4.0. Yep, that's where it collapses back. That's fine. So if it's greater than 0.5 and less than 1.5, set the power to this. Why did this value? Because the gradient going back down. That makes sense. I forgot about that. I forgot that was going to be sampled. That breaks this. Because then we're back to the problem that we had last time, where everything works, and then you have this little strip on the left. Just because I forgot that uv.y would get sampled, just like uv.x gets sampled. Oh wow. All right. Okay. Gotta shake off the midnight spider webs and figure this out again. Um, how do we do this? Oops, too far, too far. So before we were doing the radians around this, doing the quadrants I like because it gives us the value of x is going to be the distance around the quadrant length. And what does uv.u give us? So let's comment this section out again. That's that's odd. That's odd. Why is it like that? I thought it would go from like 0 to that. But this is going from one corner to the other. Did we not adjust that for the length? We did adjust it for the length. The distance divided by the length, that should give us a value between 0 and 1. Just going to stare at this and think. So each one of those points has a location, and we have to turn them on and off based on their location around this track. If this was a circle, it would be easy because it would just be around and we could animate that quickly. We know how to do that now. We could do the opposite for the UVs. Here and flip this on the way back. So it goes from 0 to 1, then 1 to 0. Is that helpful? I don't know. I mean, that's just like, is it left or is it right? It almost seems as though, in this case, we might as well do the whole track in uv.x, right? But only half of it go from 0 to 1, then 1 to 0. All right, goodbye quadrants. Goodbye. I don't know what to put in y if we do that. Because if we do that, well, we might need to know which quadrant we're in. So we can flip this. And we just need to know, are we left of center or are we right of center? Flip. So how far are we around this? Oh, we do need to know the quadrant because if we're in this quadrant, then we need to add the previous quadrant to it. And same with the other side. Let's say that this is the quadrant distance. I recently learned that Control A increments numbers. It is my new favorite thing in Vim. And Control X decrements them. That is fantastic. Fantastic. I love that. It's, I never knew that it did that. Since, I don't know, it was this week. It was this week that I learned that. I know, right? Wait, are you saying you didn't know about this either? Like Control A just increments numbers? Control X decrements? Yeah, it's awesome. It's great. And you can, yeah, you can use it in scripts, right? Like if you, do a little recording or something and you replay that. Or like if I needed to increment each one of these numbers, go here and be like, boom, done. fantastic. I think it's just built in. I think it's just part of Vim. All right, so if we're in here, the more you know. Yes, exactly. This will just be quad distance. Same with this one. And then these two, plus quadrant length. Except the latter two, let's see, this is quad 0, 1, 2, 3. Now these have to actually be flipped. So in this case, we're going to be counting down. So it'll be like full quadrant minus the quadrant length. So quad distance times 2 minus that. And then this would be coming back. Oh, quadrant length times 2 minus that. Okay. Flip that times 2.0. All right, and that should give us the U and V correct. Then my Starlink rebooted itself last night. Let's see. One thing that's interesting about it, I go to check the version numbers after I notice this. And guess what? It says that the router is unreachable, even though the data shows up here and the data is coming from the router. How does that work? I don't know. I've been tempted to actually dig into this and see, do some snooping and see how they're getting the data, so I can actually put it on screen. Yeah, it says that it rebooted how long ago? Like 4 hours ago. So let's try this. Anything to save? No, we're good. 0 to 1, 1 to 0. Oops, let's get this. Are we still showing Y here? Oh, we're showing UV.X. That very quickly goes up. That should not be that. Oh, it needs to be a color. Vec3, boom, all the same. Yeah, same thing. So those are not the right values. Oh, because this is actually between 0 and 1, and then whenever we add the quadrant length to it, it goes whoop, out the window. Okay, so this is actually half the value, and this would be adding 1 to it. Quadrant length times 2. Now we could quad distance. this gets it from, we had this and this, so that should only be half of it. Because we want the first section to only be between 0 and 0.5. In which case this is still wrong. It should be 0.5. And in this case, we should be starting at 1, subtracting the quad distance, and then here 0.5. It feels like it's backwards. This should have gone all the way up to 1, stayed at 1, and come back to 0, but this is too bright here. Am I sure that's quad 2? Let's double check that. So for 2, it's going to be false, false. What is quad distance? So if we have a box and it's square and it's 10 on each side, and we're in Godot, we have to flip the value of y to make it positive. So it'd be 10 down, 10 over. We would have 20 here. Divided by the quadrant length, which is, see, width and height divided by 2. That's not right. It should be like divided by 4 for quadrants. All right, then divided by that, that should be 5. So in this case, we'd have a value of 10 plus 10 would be 20, divided by 5 is 4, divided by 2. See, this quad distance thing is just bogus. We should probably do those inside of this, because knowing which quadrant we're in, then we could subtract. All right, let's move that in there. So for quad 0, which is this section here, we start the racetrack not up there at the top. Toggle bit. Rust, yay. Yay, Rust. How you doing, man? How are you? Hope you're having a good Saturday. We might get rain later today, spoiling my hiking plans. But also I have to go to the hardware store and pick up some stuff to mount Starlink. Yeah, doing all right, just chilling. Trying to figure out the shader stuff. The future lies into Lua. Oh my goodness, Zetacron. So this is ours. This is our 0 point. This is our 1 point. Yeah, and talk about we're trying to get this to have this cool glow going around the edges. So working on that. Oh, and I could probably do for UV do the top or bottom. Let it know that if it's a top or bottom value. Oh, that would work. Yes, I think I just figured it out. Um, it might seem stupid or obvious once it's said, but so UV dot Y will be equal to the vertices Y value adjusted by distance for time, and the UV dot X value will be vert dot X, also the same way, but they will be um, from 0 to 1, both of these. Oops. And then we will just adjust it for time. Oh, that seems kind of obvious now that you kind of look at it. I'm still not sure how this is going to affect the corners though, because the corners are rounded, and so how's it going to go around the corners with just this and not taking into account the roundness of the corners? We'll see. Might be okay. Might not. All right. Yeah, and then we'll mod time to know which section we're actually doing in the shader. All right, so I think this gets simple then. We can get rid of quadrant length. And what is this going to be? U is going to be the vert.x minus, what is it, self.left, right, adjust it for 0. Except these are all in like local space now, so this should be able to just say divided by width and y equal to vert.y divided by height. All right, that all would go away. Same with all of this. But does that account for time? Because that just gives it a gradient of 0 to 1 all the way across. We'll see. Because I think it'll travel across the top faster. See, that's the problem here. It's going to travel across the top faster than it travels across the sides if we do it this way. So we can't do it this way. Because if you have something like really short on the sides, it'll like spend, let's say it's a second to go up this side, and then a second to go across the top. So it'll be moving very, very quickly across the top instead. But if we did this, going back a little bit further, from here, traveling up, over, and down as 1 second, and then back would be another second, then we could take into account the whole length. Okay, so let's say the half track, let half track is equal to width plus height. Right? Because it's one full width plus two half heights, and two halves is a whole. All right. Yay, homeschooling. I wasn't homeschooled, but we do homeschool, and it's been a great experience. Continuously learning. All right, now to figure out where we are on this, we will take the width. It's going to be vert.x divided by width. So just vert.x. Now to that, well, this is if it's above center, right? So the vertex.y, and we're not flipping these, so this is a negative value because Godot is like 0 to -1, obviously, but the bottom will be at -1 for this. We start drawing these rectangles at 0 and draw down to -1. So if vert.y is less than or equal to 0.5, which would be center.x, then we do one thing, else the other. I think we can still get rid of this. Okay. Return a vector 2, expected that. Now this, if it's below 0, this just goes across, and that's fine. If it's below center, it's above center, pardon me. And then in this case, the y is going to be a negative value, so we need to take negative vert.y divided by the height? No, not divided by the height. Oh, and I see if we are left of center, then we have to add the y again. See, because we're starting here, maybe we go back to the quadrants. My wife's giving me this come hither look, but I think it's because I need to lift something heavy. All right, give me a minute. All right. Yeah, just it's probably less than 60 seconds there, but who knows. Quarter track is going to be equal to a half track divided by 2. All right, so we scrap that, go back to the quadrants. And you know what? We'll just return from the match. So if vert dot x is less than or equal to center dot x, right? Vert dot y is greater than or equal to center dot y, because that means it's above it. And if we wanted to keep that a little bit more obvious, we'll flip that, say it's less than or equal to. Having the negative on the y helps remind me that the element is flipped. All right, so in this case, if it's left and above, it's going to be true, true. Zero. All right, let's do quadrant one. Quadrant one will be false, true, because the y value for the vertice will be above the center. Now for quadrant two, so it's going to be false and false. And quadrant three should be the remaining possibility, which should be true, false. However, let's verify that. It's going to be left of center, yes, and above center. Good. All right, no, in this case, we need to produce a vector 2 for this. So the distance from that 0 going over to the 1 here, what is the distance? Because in this case, if they have a y value, the distance, we'll have to flip that. So vert dot y, negative vert dot y, plus the x. Okay, and that is then divided by the half track, because we're going to go from 0 to 1. All right. And y is going to be equal to, I guess, 0 in this case. Because I just need to know, is it the top half or the bottom half for this? And here, because it's in quadrant 0, we'll say that the y is, we could give it that gradient, say, oh, it's 0 to 1, but it's going to give us a gradient anyways. So let's just say the ones on the top are 1, and then only on the sides will it give us a gradient. Y is 0 to 0. Top half of the track. All right, now for the next portion, u is going to be equal to a quarter track, right, for the half height here. Well, it's not going to be equal to a quarter track. It's going to be equal to half height, isn't it? Because we need half height. No, because it will be the whole quarter track. It'll be this plus the height, and then, okay, that's a quarter track. So that's quarter track plus, no, see, now I'm trying to add x to it. That's not going to work. We'll do the half height. I know, we could just divide that by there, but I just wanted to say half height. Half height plus vert dot x. That went sideways real quick. Uh, half height plus the x vert plus the y. Oh, and that's why we had the little slant, the little tilt. Oh, that's okay. Because our borders have thickness, so the part of the border that's lower is a little bit further because we're adding y, which is why you'll see the little slant because of the distance gap there. Should look all right. And in fact, giving it a little larger border might be an interesting effect. Okay, but where are we going with this? Vert x plus vert y plus negative vert y divided by half track. All right, and this is still that. Move this up there. Vector 2, new. so it matches the shader. All right. Now for quadrant 2, we add an entire half track, but we're coming back from 1. So this value should be starting at 1 and then subtracting a value from it. So let x equals 1.0 minus, it's going to be minus x minus, and how do we do the y in this case? If we're on the right side, I think we just add it in this case. Hold on, now I need to verify these are correct. Yes, in this case, we're adding this, no, this should be half height minus that. That's wrong here. Hold on, let's go back. Because of where the starting point is, right? If we're half height, that needs to be 0 minus that. So if our track is 10 tall, half height would be 5 minus minus -5 minus -5. Okay, that does the subtraction just fine. All right, but then on the right side, we add it. Yes. Okay, now in the second quadrant, down here, we add it. See, I gotta get better at my commenting Vim abilities. Let's close some of this. What else can we close? Not pretzel. Discord, we could. All right. All right, let's bring this over. Deep Pope. Commentary. I like his naming. Yeah, and I need to get better at commentary. Comment stuff out, use GCC to comment out a line. Takes account, okay. GCC to comment out the target of a motion. GCC in visual mode to comment out the selection. GCC in operator pending mode to target a comment. You can also use it as a command. Yeah, so how does comment with motions mean? Like GCI right bracket to comment what's, oh. Wow. So GC, hold on, GCI bracket. It just that's inserting a bracket for me. Am I typing the right things? GCI. Yeah. Oh, do I have it installed? Oh, you sneaky, sneaky toggle bit, pointing out obvious things. Do you have it installed? Blah 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 blah. Autocomplete. I have nerd commenter. Is it just called commentary? Yeah. Was it Vim commentary? Vim commentary. Okay, load that. Plug. Do we have to do a clean? Might have to do a clean. No, I don't. Hmm. Actually, I'm gonna do that. Plug install. I had a lot of stuff just sitting in there. Okay. And commentary is just about using motions, which is fantastic. Oh, oh, look at that. I love you guys. That's going to change everything. I mean, first this week we learned that Control A increments numbers and Control X decrements numbers, and now this. That is just so good, so good. The technology, yes, we have the technology. It's so funny that we've spent so long, so many decades building editors to edit code. But we do have like a 5 second delay that's artificially added by us. And thus far, no drop, no drop, only a couple due to rendering lag. Interesting. The other thing we can check is the buffer, because we might have run out of buffer. Yeah, like right now we're buffering. Oh yeah, we hit. Yep, I'm on Starlink, and we ran out of our 5 second buffer. Yeah, I mean now it's looking all right. It caught up. This is our Stitch server and Stitch client, which we use for smoothing out um, kind of networks. We had an artificial delay. In this case, we're adding a 5 second delay. And if anything happens with Starlink, because sometimes we get a little Starlink hiccup, Let's see. Probably show this on the phone. Let's see, it's probably within the 5. Actually, it doesn't look like there was too much, but yeah, let's go here. In this case, let's see if we can find it there. Ignore the crack, but you can see that there was a little bit more jaggedness over here, right? So that's where it happened. But yeah, it's working. It's working. Let's, all right, let's keep going. So quadrant two. This is going to be, because we're going from 1 back to 0, all of x, 1 minus x. We need to add, no, we already added this section via the 1, but we also need to subtract this. So if our height goes beyond half, we need to subtract half the height. Oh, Big Halsey. That's right, the new stream. We'll just, good luck finding the code behind it. See, now I can point to the code. This line right here, this is where the error is. And later today, we'll have an ASCII graph coming in from the northwest. Okay, let's go back to. There we go, now we're back. So let's say this is 10 high, and we're at 5. That should subtract nothing from it. Hold on a sec. Saturday morning requests. All right. So people are getting up early. That's 7 o'clock on a Saturday. All right. So in this case, this quadrant, we need to take out. What is this going to be? We need a positive value that we can subtract from 1. I have to approve. Computer time request. Just a moment. A while ago, I'd been teaching the kids that if they ever need to interrupt, they have to scream interrupting before they start saying what they need. And that worked. They started coming up and be like, interrupting! Like, is that polite? They say no. Then why are you doing it? It kind of worked. Well, on the older kids. Um, all right. The younger ones didn't even like bother. They don't even do the interrupting bit because they're just not at that point where they recognize that there's an interruption happening. They're like, I need to tell dad something. And they walk over and they say, you could be in the middle of speaking to somebody else, just blah, 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 blah. And they say, I saw a worm. And like it's the most important thing, and it is to them. And it's fantastic that they want to include you in their life because that goes away. Sometimes. It just depends. Like the stuff that you get included in is different. I'm just going to call this variable h, and these need to be divided by half track. I remember, now you got me thinking about kid stuff. I remember my daughter, she, was in that bug phase, right? Where, you start to notice all the little creepy crawlies in the world. And of course, we live out in the middle of nowhere. There's lots of creepy crawlies going from like this big to like really big. And she found this big ant. It was the biggest ant she had ever seen, and she had to like pick it up. And so, it was like this cool little creature, and I'm standing there, I'm watching her, and she's obviously like fascinated with the ants. And they're just going along, and she's like, she just bent down, and before I could stop her, she picked this thing up. And she went to go look at it, and as she's looking at it, it turns and goes right into her finger, and she screams. I'm not talking about you. Don't worry. Don't worry. I'll tell you later. She's she's like, "Are you talking about me? Are you talking about my sister?" Sounds like a good learning experience. Yeah. Oh, we need h. Let h is going to be equal to. So in this case, we need a positive value that represents how far that they've moved on this, which is going to be negative vert dot y minus. That's a positive value, a half height, because we need to take away that first portion. So the value starts here and goes down. Now, from there, we subtract that from how far we're going around. So we have 1, and we need to subtract that. And we're only going from there to about here, half that, because we're in that quadrant. And in this case, y is going to be 1. All right, now for quadrant 3. Now is this right? So we have 1 minus the distance that's been removed. Well, divided by half track, yeah. That looks right. Let x is going to be equal to, same thing, 1 dot o minus already half height and half width. But this isn't correct. This, hey, thank you for the follow. Thank you. As this vert dot x is going to be the full distance here, right? And we don't want that. We want just the distance from here across. But that also needs to be flipped because we're going from 1 to 0. And in this case, this would be with minus x, because we need to subtract from here over. Okay. Because if we're all the way over there, we need to subtract nothing. So if we are at full width, it's all the way over. And look, we had oh, that was wrong too. So wait, flip the height. Because if we're at 10 and half is 5, we'll have 10 minus half height, which is 5. So we subtract 5 from this. So if that's 5, say that's 5, and this is full, we should be subtracting 0 for this, because width minus that would be 0, because they would be the same value, divided by half track. Why would, oh, because we're going from 0 to 1, and then 1 from that, or that from 1, yes. All right, next one. Now in this case, we need to, we're on the left bottom section of this track, right? From about 0.5 here down to 0 for quadrant 3. Vector 2, new, x, and 1.0. X is going to be 1.0 minus, now at this point, can we just subtract the x from this? No, it needs to be with minus x. Still the same thing there. Oh, stop it. It doesn't feel right for this to be the same. Are these actually the same? Because we have to subtract the width, the vertices x from the width. And because we take the width, we need to know how far you've come back. I'm gonna stub in some values here. So let's say we're at 10, 10.0, right? And half height would be 5.0. This would equal, is it 5.0? Okay. Then here, our width, we have something. Let's say our width is, it's, we have a big square 10 unit box, and we're a quarter of the way across the bottom, so it's 2.5. Our width is 10.0 minus 2.5, and that gives us, well, 7.5. So then in this case, we have the half track, which is 20 because it's a square with 10 on each side, right? And half of it would be 10 plus 10. So 10 plus 10 minus 12 and a half. Good. That should be 7.5. So that's 7.5 divided by 2, uh, which gets it to like 0.25, I think. Let's keep going. So in this case, width and height, that's 12.5 divided by half track, which is 20.0. And here, of course, we have the 1.0 here. What's 12.5 divided by 20? 0.625. And that's how far from the right side we would be subtracting from 1. 0.375. That seems about right. Because that would put us down over here. Yeah, okay. I think I want like a unit test for this. Oh, that, gotta remove the semicolons from this. Okay, that built, wait for this to have to build. Go back into Godot, kill that. Yeah. Oh, and thank you for the follow. I missed a couple. If you want to say hi, please shout hi. Say hi. Are you coders? Just fascinated with the process? The top one is right. The bottom one isn't. It's a little off. I'll, I think the problem is actually over in this quadrant here, because this is all black. All right. So if we are the bottom right corner, negative vertex dot y on a 20 by 20, right? This would be negative 20 dot o minus half height, which would be negative, oh, which would be 10. And that's negative negative, so that's a positive. So the height is going to be 10. Width in this case is going to be 20.0. Vertex.x 20.0. That's 0. Now for the next one, we have 1 minus width plus height, which is 10. So 10 divided by half track, which is 20, it's 0.5. But that's not right, is it? It's point. Well, let's continue writing it out. 1.0 minus width plus height in this case is 10, and half track is 20. 10 divided by 20 is 2 point or 0.25. Yeah, that should be here. That should be half there. This should be. This isn't correct. I think the X is correct. The H isn't, or rather, the W is correct. The H is not correct because we want a value that's going from 1 all the way down to 0. So in this case, what should the value be if we are at this bottom right corner of this? We would have removed from 1 to 0 an eighth of the whole thing, so a quarter of this. So we should be at 0.25 and we're at 0.5. So this should really be 5. Oh, no, this verta y is 10 because the square is 10. Half height would be 5. Sorry, my actually that's correct then, because then the height divided by 20. That looks fine. What am I missing? Because see where the gradient is on the top one here? How it's centered, right? You have this kind of middle gray in the middle, and here you still have black in the middle. It's because this corner isn't still kind of bright and vibrant. So if it's not that side, is it quadrant 3? That seems silly. Guess it could be. But what you end up having is some very large values over here, and you can see on the right side that if we scroll in here, these should actually be mirrors of each other, flipped vertically, and you can see that they're not. Right? The only thing that should differ is the slants here, these little slants, and that's okay. It's okay, we might be able to actually fix that. It's actually the curve. But the brightness around here should stay a little higher until about here, and then it trails off. All right, we might get into unit testing here. Let's extract this out to a function. Revert to UV. How about what kind of UV are we doing? We're going whatever UV. We're going to pass in a lot of values. This is going to be one of those inline always. We want the vert vector 2. It's technically a vector 3. We're just not using the Z. Toss that in there. This doesn't need to be off of self. It says self colon colon. Um, or we just move it outside this. Toss it on the bottom. There. Okay, now we have our vert to UV, wherever we're calling it. And here, I think we need to pass some more values into this though. So we could toss a closure on there. What does this need? This needs V, obviously. What else? Okay, vert's there. Half height, half track. Width. Yeah, that's going to be wrong. I want to see if Rust Analyzer can add this for me. So I'm just gonna wait a moment. Come on. There we go. You're not gonna do it? What's this? No, it's not gonna do it. That would be fantastic. All right, half height, half track, and width. I think these are F32s. Oh, we need center? No, we need center. Come on, get out of there. Let's say, yes, you could borrow it, but is that fine? You're a borrowed vector 3. All right, now let's add our test module test. You sure glad muds don't need all of this math? What do you mean? They don't need, well, maybe a mud with a really fancy interface. Vectors be gone. I know, right? I miss mods. Are there like some good mods out there? Because that'd be fun to play again. On my MMO project, I'm hoping to have a mud-like interface. That's optional, right? You could telnet to it, or rather SSH to it, if you wanted to. So, or you use the fancy interface that has all this other stuff. I think it'd be great. One day you might make a UI for the mud. Very cool. UV um, vector to UV. Sure, that's our test. What's vert to UV? Eh, vertex UV. Sure. All right, so we need some tests in here. Vert to UV, and we give it a new vector 3. Vector 3. Oh, you're using an engine built in Python called Avenia. You love Python a lot. Best language you've tried so far? Python is really, really good. Python's really good. I like Python too. Python doesn't go everywhere I need it to, so I'm doing Rust stuff. I do like Python. I like Python a lot better than Ruby. Um, I don't know. If we were to list the languages in the order that I like them, Rust, darn you, Rust, still at the top. C, no, not compute. Followed by Elixir. Uh, Godot has GD native, and you Rust just um, compiles to a library that GD that Rust can, that excuse me, I'm saying this all backwards. You can produce a library with Rust that Godot can load. Let's see. After this, probably C++. Python's going to beat Java out. I might actually like Python more than C++. I don't know, but new C++ is different than old C++. Move semantics, all sorts of cool stuff in the new stuff. So this is really close, but I mean that's a close toss-up. Then we have got like I don't know Ruby down there somewhere. I've never done Ruby. Perl never. Python is awful when it comes to change. I think that really depends on the Python though, right? If you're doing write once, and I think a number of these languages have that. Right? Python can look gross. Ruby can. I don't know. Ruby. I don't like Ruby for other reasons. It's got too much magic in it, right? I think that's why I stay away from Ruby. Is Elixir functional? Yes. Yeah. This is, and to be fair, this is Elixir and um, Erlang. I do like Erlang quite a bit, actually. Elixir beats it out because it's got a more comfortable syntax and it's easier to refactor. But, oh, you know what? I forgot. I forgot like my day job stuff. Where do we put where do we put JavaScript in my list of likes? Oh, C sharp not on the list. Actually, I've done C sharp too. Um, C sharp, C sharp's going to be down here with Java. Um, it's yeah, but all of my experience here was with Unity, right? With C sharp, and I don't know, like C sharp and Java have the same sort of feel to them, right? Um, TypeScript. Oh, thank you, Rockerboo. I do like TypeScript more than JavaScript. I'm gonna put TypeScript in here. I probably like it more than I don't know. I like C++ more than that. I tend to favor languages that compile that where the compiler is a bit more strict. Um, oh yeah, yeah. This is it was really bad back then, and we had to do some crazy stuff with it to get assets on the glass, right? And we basically had to do all sorts of shader work and well that's more going back to shader stuff. They just didn't have good 2D support for things on the glass in 3D things, 3D projects. It was miserable doing the Python thing. Yeah, see, I haven't ever really done a lot in Python. JavaScript, I'm gonna put JavaScript. I mean, I know it really well. Does it sit before Python? I might prefer Python to it, but I think it's because JavaScript sits in a browser usually for me. And well, I you know very used to doing stuff in a browser because I've been you know basically full stack for 20 years. I've never done JavaScript on the back end ever. Browser only. Like that needs to be capitalized even. Needs a lot of tests. Yeah. Well, let me look at this. I'm gonna meditate on this for a little bit. You know what? I think I might actually put these two. It says tight. I worked on an MMO in Java. Node or not to node, yes. But I think this is my list here. Go. I've never done Go. Um, I think I would like Go. Go for me, from what I've seen, would probably sit here. If I really got into it, it would probably even make it up here. But from what I've read about it and what I understand of it, it likely sits there for me. And I've never done Haskell. No. This is your first project in Python and the furthest you got in coding. Oh yes, yes. The indentation. The Python's a fantastic glue language. Um, right. It has a lot of things written in, let's say, C or other areas, and you can basically stitch the things together very, very quickly in Python. What's my chat window font? It looks nice. It is Fiora Code. Um, I think we've even got a little thing there. Yeah, we got that. And if you want, we have commands. So, but have fun with Python. There are. This is just my experience, and it is different from other people. Um, I tend to favor things that are strongly typed. However, these are little outliers there. Um, I like that Go doesn't have inheritance. Um, I like that it has channels and it is basically designed for productivity, fast iterative processes, etc. Yeah, if you're doing enterprise stuff, test, 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 tests. Oh, you're learning Lua right now. Oh, Lua's not on here. Lua for me is more of a fascination. I Would I choose to do stuff? I see. This is getting into which tool for which job. But if I just had to pick something to play with, Lua would be probably below these for me. No, 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 it wouldn't. if I was making a game, let's say I had to make a game, and of course, let's see, and I had my choice. Lua's, yeah, right next to Python, I think. You don't plan on coding professionally? Well, remember, professionally just means you've made money at it. So, yeah, if you make money on your game, congrats, you're a professional coder, right? Let's see. Hi, professionally. Prof- Profession, I don't know. I'm a professional. I would be careful with that. You might be surprised. I'm sure there's some place where mud is making money. Engaging in an activity for gain or as means of livelihood, extremely competent in a job. Yeah, I mean you could actually get there. But Lua would be there. Let's see, which ones of these have I actually done? Of course, you see Rust here. Oops, undo that. Done Rust, done C, Elixir, Lang, C++, Go. No, never done that. Yes, 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 yes. I've never done Ruby. And which ones have I done professionally? For money, I have not coded in Rust for money, but I hope that changes. C for money, yes. Elixir and Erlang for money, yes. C++, yes. TypeScript, yes. JavaScript, yes. Python, no. Lua for money, no. C Sharp, yes, and yes. So these are the ones I've done professionally. Just don't write backends in it. One of the reasons I learned Erlang was to rewrite a Python backend. And oh my goodness, it was incredible. We had seven machines, seven, there were seven VMs at, I don't know, 80% CPU. Scala, never done it. I don't know where Scala would fit in here for me. I don't know enough about it. I know that it's a functional language. I mean, you start talking about like Scala or let's say F sharp, right? Then, Haskell I've never done. A bunch of those. I don't know where they would fit in. But we had seven VMs at 80% CPU running a Python service. I learned Erlang, actually, not Elixir. Elixir wasn't out at the time, but I learned Erlang and rewrote it. It was faster. It replaced all of these with one VM at about 6% CPU. And this just gets into the right tool for the right job, right? And they actually made me set up a second VM for redundancy. So like, no, no, no. If that crashes, this is all broken. I'm like, okay, well, what if we had two? And and Erlang is just built for this, right? If you think about what Erlang is used for, Python was basically doing exactly what Erlang was meant for, right? This thing was just shuffling bytes around. And occasionally doing CPU intense hashing and stuff like that on it, but only occasionally. It was mostly a proxy. So this is like Erlang's bread and butter, but not Python's. So I imagine that Python was doing a lot of copying, a lot of, packets having to get copied over and over and over again. But yeah, we added a second VM just for redundancy. And then it never crashed, ever. Our service was faster. I mean, it was substantially faster. People noticed it. So Python is mostly C Python anyways. Yeah. And they had already optimized this. They had already optimized it. It crashed with style. What would happen though with the Python ones? They would crash when these guys crashed. They would crash and hang at 100% CPU. And that's how you knew the box was dead. And you would restart it. You would see one go red line and you'd have to restart it. And there was never a stack trace. It was in one of the I don't know, it was like I don't remember if they were using Twisted or one of those other high performance IO things for Python. I don't remember what it was anymore. But it was a bug in that library, and occasionally we would hit it, and it would just spin. But it was a lot of fun. It was great learning Erlang. And when you present your boss and you're like, hey, um, and because I was part of the back end team at the time, there were like three of us, right? And then there were two of us, and then there was one of us. But I did this, and the other people didn't leave because of Erlang. It actually made our jobs easier because we never had to touch it. Um, but but that gig, can you imagine going to your boss and saying, "Hey, I had this idea and I tested out this Erlang thing. Have you heard of it?" Like, yeah, I've heard of it. It's like this old dead language. It's like, great, you've heard of it. Um, I replaced all of our Python instances with it, and then you get this like terrified look on the guy's face, right? Like, the good news is it's not crashing, and we only need one instance, and it's faster, and you just keep going on and on and on. And like, okay, great, leave it. So, but yeah, that was a great project. I don't even know if that was when I was doing stuff at Zobni, and that was forever ago. They got bought by Yahoo, but at the time we were the largest largest API user of LinkedIn. All right, so like we sent more traffic to LinkedIn than any of the other API partners. That was crazy, crazy. Oh, and the Erlang upgrades, the upgrade to Erlang actually improved our connection with LinkedIn, and it just got even better because it decreased their load because we were able to maintain persistent connections and reuse connections to LinkedIn, um, which Python hadn't been set up for, right? So for every request coming in through Python, we'd have to make another request to LinkedIn. But Erlang, we could just set up a client, and I had 100 consistent connections to LinkedIn at all times. And because we had a huge amount of traffic and we had a lot of those busy all the time. But it was crazy. We were we had so many API calls to them. All right, now what's wrong? Oh, yes, expected output here. We're doing unit tests. I forgot about that. Vector 2. Yeah, that's our UV. Now we're going to write some simple tests. Now, for a square with with 10, with, I don't know, length, size, dimensions. If we were to convert this, let's say our first point is going to be at, what are the values here? The vertex, center, half height, half track. I don't, maybe this should be on that thing, but then I'd have to create a border box. I don't want to create a border box. Can't say you've ever touched Erlang, but it sounds interesting. It is fantastic. It really is. My MMO project started out as Erlang, and I got further in less time before I rewrote it in Rust. Um, but of course, I've made more progress since then. All right, so this vector is going to be at, let's say it's at 0, 0, 0, which is the top left corner of the rectangle. Now, we have to give this the center. You ran a Twitch stream discovery site in Elixir and we'll let it run for years without it going down. Yeah, let's sync with Twitch streams every 5 minutes. It sounds about right. It just doesn't die. Thankfully, Twitch stole all the ideas. uh, it's going to be a vector too. 5.0, 5.0. All right, then we pass in center. What are half height is 5.0. Let's just let half height half track is equal to 10.0. Width. All right, now we need a width. Their new discovery section is what you were trying to make. Oh, interesting. You found the stream thanks to the suggested smaller communities. Well, lovely. Oh, that's cool. You stay away from large streams anyways. Yeah. I mean, at what point is it a large stream? Is it at 50? Is it at 100, 200, 1,000? I mean, 1,000 seems like a large stream to me. 500 seems like a large stream to me. 100? I don't know. I mean, in terms of like the amount of chats that you'd have for that. Yeah, in this category, what the chickens? What is it? The chickens and the ducks are like the largest. Maybe the earthquake sim, earthquake monitor. Well, maybe what occasional streams by some people. Yeah, well, there's almost no chance the streamer can even read what you wrote. Yeah. Oh, this has to be a reference. I was going to do with a temporary on that. All right, so let's get the value, let actual. We're doing test stuff. We'll have expected and actual. What is our expected here? Hmm. Vector 2 colon colon new. Now because we have a square, this would be, I think it's going to be like 0.25 here, and the value of 0, 0 should be 0 to 0 for that. I think that'd be on 200 users just merge into a single blob called chat. At that point, the stream just turns into a never-ending stream of spamming emojis, memes, and emojis. I've never seen that on Twitch. I don't go into the big streams. Yeah, lurkers who don't want to interact. No, vector 2 here. Let's start equal. Actual expected and our, yeah. This would be a quarter of the way around the top half of the track. All right, give that a test. Oh, let's turn off the compiler. That's gonna trigger whenever we do that. Mm. Oh, and thank you for the sub. Oh, thank you for that. Oh my goodness. I really appreciate it, guys. Thank you. All right. All right. So this is giving us zero point 0.5 when it shouldn't be zero point 0.5. That's just wrong. And let's figure out why. Okay. Why do we think that it should be a quarter? Because a half track is from 0 to 1. If we're in the top left corner, we've gone around. Sorry, we're going to take our box here, drop that in here, save, format it. We're going to go from 0 up to this point here. Let's try to make it a little bit more square. It's supposed to be square. All right, and if this half the track is, this would be 10, this would be 5, and this would be 5, we made it a quarter of the way around. So that should be 0.25. You know, I should probably make this smaller. Just bring these in. What's this going to look like? Because we're going to need more of these for the tests. That looks square, and we're just going from 0 to 1. Okay. So maybe the bottom one is more correct. So let's fix this. That would have been in this section here. Let h equal to, what is this? Half height minus that. Right, because we have to flip it. Vert.x there, toss that over there. Okay. So now we can reason about the pieces. And in this case, x should have been 0. Right, so this would not have had any effect, meaning that our bug is in here. Half the height, that's going to be 5, minus vert.y, which is 0. Are we just dividing by the wrong value overall? We're dividing by half the track, which is correct because half the track is 20 and we only went 5. So why isn't that? I don't see it. Let's cargo test. Come on. No capture on that. All right. Come on. You can do it. It's at 5. Left. That shouldn't be the full track. Is my setup wrong here in the test? Half track. Score with a 10, that means our half track is actually 20. My tests were wrong. All right, that means that should pass. Yeah, I don't doubt that that's going to pass. Cargo watch dash x test dash dash. I'm gonna check on something. I'll be right back. Dog's barking. Give me 2 minutes. All right, we are back. Okay, so that did pass. Let's remove that DBG. Good there. Now let's do the other sections. Now in this case, we're going to do the top right. Should be 7.5. And the X on this is going to be width. Seven five. Okay. Now let's do the bottom right. And the bottom right is going to be width and width. It's a square. And then you go back to 0.25. And then 0.75 would be the bottom left square with a 0 there. All right. Oh, one failed. Oops, what is this? I don't remember the command. 672. See, yes, and that's what we're seeing. Okay. Oh, the actual is 0.75? Oh, that means that this was correct. This one was actually this one here should have been 0.75, and this one's 0.25. Are these just backwards? Because this one's, if you look at the circle, right, we go from 0 to 1, and then from 1 back to 0. So here that third test has its point here at width. So it should be 0.75, right? Going from 1 to 0. And then the last test should be at 0.25. So 0.75 and 0.25. Okay. 662. Okay, let's fix that then. So in this case, we have unit test for the win. X. Or some T while I'm at it. Oh, we need to do the no capture. It didn't get the no capture, did it? 664, yes. Oh, these are backwards. It didn't go into that quadrant two. That's their problem. That's why it flipped. So the center.y, if the vertex is less than that, hey, good morning, Supercuber, Jummit. How you doing? It's good to see you. Now, how are we going to do this? Okay, so this vert.y, center.y is going to be a value, right? Because this is a cube, it's got a width of 10. Center.y is going to be 5. But vert.y, in Godot space, this is a negative value because the height is going to be negative 10. So half would be negative 5. So if we take the negative of that, or flip the flip the sign, and it's less than y, it should be quadrant 2. And quadrant 2, oh, no. Quadrant 2 is actually the other one. Is it the x that I have flipped? I flipped the x's. The y's are correct. This is true, and this is false. I kept focusing on the other half. Oh, wow. All right. That would explain a lot. Too much. Explain too much. All right, now we failed at 664 again. Yes, for the third one, that's at width, right? It's down and at the bottom. Visualization is such a critical skill for coding. Yeah, and and here you can see our attempts at visualization. Let's clear the board. All right, now we can zoom in. So for those just now following along at home, we've got a rectangle. All right, and we're saying we need to create UV coordinates. Okay, so we're dividing this in half and saying we've got a top half and a bottom half. So we've got two tracks. And the left point, 0, and the right point is 1. Okay, so it's actually that little point right here. Right, that's 0, this is 1. And when you go around the track this way, the value increases from 0 to 1. And then when you go around the track this way, it decreases from 1 to 0. So that we can use those values in a shader to produce a nice little glowing animated effect. And the reason that we're doing it this way is because these boxes can be arbitrarily shaped. They're not always square. If they were, we would just probably go straight around them. But we need to know how far so that we can calculate time. So that given a time, we know which spot on the track is supposed to be glowing. Now, this test right here is for testing width and height of 1, which is down here. All right, this is the third test. So this is the one we're looking at. This is the fourth test. And here we're getting that it's only at 0.75. It's at 0.25 when it should be 0.75. So we're expecting 0.75, and our actual is 0.25 at the moment. Let's just verify that. 25. Yes, left and right on line 664, which is there. So that is either going into the wrong half. It's still going into the wrong half. Did I fix it and then unfix it? Here, our x is less than center.x. Oh, that should be false, shouldn't it? That wasn't the problem. Yeah. Okay, just do it. Save it, test it. That should be getting hit. Oh, Clippy, like we didn't know. See, it didn't even panic. Didn't even panic. Which one is it going into? This one? That moment when the compiler is smarter than you, which is most of the time. Wait, neither? Okay, I'm guessing my test is wrong then. My test is wrong. This needs to be a negative width. Oh my goodness. Right, because Godot, it needs to be negative. So if we were to draw the Godot coordinate space on top of this in yellow, we would have 0, comma 0 up here, and then we would have 10, comma negative 10 down here. All right. Deception. It's valid. It's valid. Okay, now it hopefully it'll panic on the last test. Okay, so it did do the debug, which is what we were expecting. But why is the UV set the way it is? Or the V? Because here we have 0, 0, 1, 1. Another test bug. Yeah, another test bug. All right, so that's good. At least that's validated. Y increases positive as you go down? Uh, no. Y goes negative in this case. It's using this standard coordinate system, right? Where this is positive, this is positive, this is negative, and this is negative. Writing the test wrong first is ideal, right? Uh, do as I say, not as I do. All right, so we have that. It's good that we're reasoning through this, though, because maybe all of this is correct and the shader's wrong. Did we save that? We did. Okay. Can you link here? Yeah, go ahead. Okay. So it's all fine. Fine, fine, fine. Uh, but we're not using the 2D coordinate system. We're doing a 2D UI in 3D space. Yeah. So this technically is in 3D. This rectangle here is actually a tessellated shape. Same with the fonts. So like all of these, if we zoom into this E here, you'll eventually get to the point where you see the the, the vectors, right? Like here, and the straight line to there. Right? So we have tessellated fonts and stuff, which is pretty cool. All right, we're gonna restart Godot so we can load up that library. Let's make sure it's compiled though. Cargo build. There we go. Come on, Godot. There we go. Oh, I resized the wrong window. I do that occasionally. All right, now it's still doing the same thing. I do not understand why these gradients are different here. The top one looks correct to me. The bottom one doesn't. They should be going from 0 to 1 and then 1 back to 0. Let's double check here. We should have this just being the uv.x. Yeah, uv.x. That's what the emission is at the moment. But you can see how this is slightly wrong. I wonder why. Why is it like that? Oops. Hmm. We just verified that the four corners, the values along there are correct. And let's verify like a midpoint across the top. Maybe the max point is in the top right corner instead of the middle right somehow. I mean, it could be. That's a interesting observation. Because I mean, this does look a little brighter there, doesn't it? Let's go back to the front view. So maybe this is incorrect. And it could be due to the fact that if we zoom in, you'll see that they have these striations here. That does seem a little brighter, doesn't it? Let's set our world environment bloom glow to threshold of 1.0. There. Now we won't have any glow, just the values. To me, Well, let's stretch this out. Let's say the text for this is larger. Yeah, there we go. Now you can see it's more of a problem. What? Why? Why did it? Okay, I'm gonna reload that. Wow. Just wow. The thing that we didn't test could be the inputs to the function. Half height, half track, width. Here we have center. Width, height, height, half track, and center. Center, half height, half track, width. You know what? Let's put these in the same order that they get provided. Because what if I'm actually calculating width and height wrong? That would screw this up. All right, I'm going to close it and reopen it. UI test. There we go. So we have the center, which is 7, -3, and we can do a little transform here and get a grid on top of that if we rotate it by -90 there and look from the top. There's our grid. So center being 7, 7 1/4 by 3 for this. Okay, 1, 2, 3, 4, 5, 6, 7. About there. Yep, and 3 down. It's about right. Okay, so center checks out. Notice that the y is negative here. Then we have half height. Oh, which is the same as center. Makes sense, right? Half the track. That would be. This doesn't seem right. Because that should be twice the x here. Yeah, because width is 14. Half track's wrong. I mean, half the track is going to be the width plus the height. So half track is our height is wrong. This is -6 or something, right? So we're at 1, 2, 3, 4, 5, 5.5, something like that. Well, what was it? It was -3. So our center is -3. This would have been 6.2. And self.top is 0. Yeah, because we set the top to the origin for this stuff. Oh, uh-oh. This is a border box though. And if we had a margin on this, this is much, much different. We do have a margin. Set that back to, we have to take that into account. Okay, paddings on the inside doesn't matter. Border is, is actually the thickness of that. So we say the top is like 0.5. You can see it gets a little bigger. The bottom 0.5. Let's increase our radiuses to 1. There we go. Just so we can see it a little bit more. So it turns out that I skipped a lot of information here. Our top and left are actually 0 and 0, right? Which means that our, oh, that's not true. Those are actually provided by cassowary. And then the object is actually inside of that space. Okay, so let's get width and height correct. So in this case, our width is correct. I think it's just our height that's wrong. And if this is, say, -10, then we do that and it becomes +10 plus the top, which is 0 to 0, right? It's not working. Because top is also a negative value, isn't it? Wait a sec. Oh, these are cassowary variables. So I don't think they're actually negative, are they? Self dot top, self dot right, self dot bottom. I think we actually have to flip these for Godot, but these are actually in positive. Let's just double check that because I'm second guessing myself a lot right now. We'll see. We'll find out. It's a good idea, Super Cuber. Okay, yeah, who knows what that is. Um, oops, let's get that not to cover this. Top right, bottom left. Left is 0, top is 0. Right and bottom, they're positive. Look at that. Short AFK break. I Yeah, maybe. I don't know. It's just that I forgot that this value here is not negative. Top and bottom are actually positive here. But thank you for the suggestion. Yes, those shower moments, those restful moments where everything is just kind of brewing in the background. So in this case, the height is just the bottom minus the top. See, in this case, bottom is there. This is actually the inner one. This one down here is the outer one. So our top is 0.2. Bottom is that. Or right as you wake up. Yeah, when I hate the ones like right as you're waking up though, because those for me are the hardest to like grab onto. I feel like, oh, I figured it out, and they're like, what was the solution? Like, did I figure it out? All right, so bottom minus top here. So now we have a working width and height. But our center has to be inverted because of Godot. Thank you. Height divided by 2. Width divided by 2. We do not need the parens on this. Oh, you tend to have very lucid dreams? Yeah. I get that occasionally. Not very often, though. Okay, now I'm suspecting that these are closer to what they should be. Let's give that another build. After a long day of coding, it's full of coding related dreams. Yeah, I don't like to code so much that I code in my dreams. That that just exhausts me. I've done that before. I've solved problems in my dreams. I don't like doing that. Whoa. This is like the opposite now. Unpaid overtime? Yeah. It's like, that's my time. Oh, you know what? We're going to debug these again. So the center is 7.5. That's a very specific. Oh, that's the outer box. 8275. I think the inner one was actually a little wider than it is tall. Yeah. The center. Half height is the same as center. Yep, just flipped. Half track is 8. Half track is wrong. That's 9. Yeah, that should be in the teens. Well, it's width and height, right? Field Marshal, good morning, kind sir. Should try to make Rust using Rust. Oh, like the game Rust using Rust? I've never played it. I've only seen it like on the side. I've never gotten into that. Actually, the thing that I recently saw was Osu. Was it how do they say it? I've heard it pronounced different ways, but it's that. Oh my goodness, that's so fun. It is so fun. All right, so we're going to add width and height to that and get that because we should be able to see that half the track should be equal to those two things added together, as is obvious here. And half height should be half that. Oh, this is pretty fun. Yeah, yeah. It's a little laggy for me because I have to play through Wine. Oh, you couldn't get it playable in Linux? Yeah. All right, let's see. So we have center. Well, we have width and height here. So our width is 18, our height is 5, and our half track is 23. That's looking pretty correct. Our half height is that. That all looks correct, doesn't it? Those all, because the center is going to be that and that. So why are our values all really high now? We don't have any zero values. It's the fault of our text. Whenever you remove a character, it's actually redoing a lot of stuff, but it's fast. It's so cool. Okay, it's drawing the same way even when we reload that. And our glow isn't going to have an effect here, even though we had set the HDR threshold. Previously it was like 0.5, zero point 0.8 might be a little better. So we don't get other things glowing on the screen. So when we do like a zero point 0.2, get other things glowing, or the widgets and things, like these start to glow. Look at that. That's kind of cool. Everything else starts to glow. Let's do 0.5. Let's put it back to where we were. Yeah, we need to get that back to 0. Because this should be 0 here. All right, let's test a rectangle. You know what? Let's leave that one. 20 by 10. Width of 20. Height of 10. All right. So the center of this is going to be 10.5. Right. Oh, you know what? Why don't we just grab our code from, where is it, here? Use the same thing and just give it inputs. All right. In this case, we're going to have width of 20.0, 10.0. All right, now we have the same setup. But now our width is much further, right? So in terms of this, how many do we have? One, two, well, it'll be a sixth of the way around. 1 divided by 6 is what? 0.16, yada, 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 forever. And that's for the top left corner, right? Let's run that. I want to see, am I gonna have to use like matches or something? What's the epsilon on this? 'Cause that should get us pretty close. Oh, so that worked? Oh no. Left is, so it's still 0.5? Oh, no, no, no. Okay. And that was for this one, right? Oops. Uh, cargo test. Yeah, 648. So we have half height, vert y. So we add the x. X is 0. Half height is 0. So that's, excuse me, half height is, what is it, 5 here? Because we're 10 by 20. Because the vertex is actually in that flipped Godot space where we're doing 2D and 3D, so we're using the 3D coordinate system. So we have to flip it there. H, W, X. Because then we divide that by, we're doing no capture, and where is that debug output? X is less than center.x. Should be. Oh, can't do that there. Just wanted parity. Okay. Debug, debug, debug. We'll see which one it's going into, but I didn't think that would be such an issue. Center to Y. All right, so 610. We're in 610. Ah, oh, okay. Our little truth table's messed up. Wah, wah. Okay, vertex.x less than center.x. That's fine. Why did we end up down here? Well, that's true. And the other one is false. Ah, I shouldn't have flipped that. That's 610. So it's going into true false. So yes, it's on the left, which is what this says. It's on the left. Right. But y should be less than or equal to center.y. And dbg vert.y and center.y. How in the world does this happen? Like we've flipped that, I don't know, two, three times now this stream. And each time I'm certain that I have it right. And yeah, here we are, flipping it again. All right, so vert.y is 0.0 and center.y is 5. Why is the center 5? Because our tests are wrong again. See, center in this case should have been a negative value. Oh, there is a negative. It's over there. It's -5. And 0 is not less than -5. Zero is greater than. It's above it. Where's our function? All right, there we go. It's gonna be so much better this time. Now we should go into the right branch. That one test will pass, and the next will fail. Yes, yes, yes. 664, that looks about right. Let's go to 664, and this is the next test, yes. And that is a correct value. That should be there, and this one should be 1.666. And then the whole thing should pass. Oh, it failed. It's where? 674? There's that bug we were looking for. Because these two are actually on the right side, the center ones. So they should return the same value. Interesting. So, and that's returning 0.5. That should be quadrant 2. So we should have seen a 603 just before that. We do see 603. Okay. Negative y minus half height. Not seeing it. Hmm. Y'all have weekend plans? I got 15 for H. For H, 15? Okay, well, that's where our problem is. Rust, good morning, Bite Rot. How you doing? So in this case, our H should be, let's see, our box has a height of 10, but this value, it should be 5. We should be getting 5, not 15. Not 15. Half height minus negative vert, or just plus vert, because vert's negative. I do this just to remind myself that vert is, the y is inverted. Okay. Oh, you've been meaning to learn Rust. How am I finding it? I love Rust. In fact, earlier we were talking about our favorite languages. We'll be equal opportunity favorites there. Um, Rust, it has gone up to the top for me. And the ones with stars are the ones that I've done professionally, like in my career. In descending order, yes. So Rust, my favorite. Pearl, Ruby, are probably on the bottom. And some stuff, some notes about how I used it before. C sharp would be higher on the list. C sharp for me is a lot like Java. It's just a big framework, and um, I don't know. It just doesn't have the same feel for me. I don't know why. I feel like I'm more efficient in Rust now than I am in C sharp or Java. I like the standard library better in Rust than C sharp and Java. Have I seen Gleam? I have not seen Gleam. Oh, you've been doing a lot more C++ as of late. Yeah, taking a liking to it. The C++ as of this past decade has gotten a lot nicer. Those 3-year iterations add big features every time. You start out with C sharp? Yeah, it's like a fair few of the syntactic sugars they added. Yep. Safe, friendly. Yeah, I feel that there's like a lot of new languages coming out recently. Performant, Erlang compatible. Oh, it's on top of beam. Oh, that's fantastic. That's cool. Well, I'm glad it's getting some traction. Beam is fantastic. I mean that is just an amazing piece of technology. And for me, that's one of those things where why these are up here, it's because of Beam. Sorry, my wife was showing me something. All right. You see a transparent heart. Now it's opaque. I don't know. Like this is easier for me than like this. My thumbs just don't. I don't know. All right. So, okay, give me just 30 seconds. I have to approve computer time request. Okay. There we go. Back to it. So, what are we building a UI system for? What sort of game? Ah, great question. And let's see, what's our command for this one? Um, I actually don't remember what the command is. Control game. That's this one. Yeah, for little kids, right? They have to send a request to be granted time. They can't just hop on there and do whatever they want whenever they want. Otherwise, chaos breaks out. Oh, that's funny. Yeah, that's for the other game. Legacy, we actually have two things going on at the moment. So, in fact, the UI elements from this are going to be used inside Legacy. Yeah, yeah, it's kind of the same way here. Covetous, Coviticus. BIOS password, OS password, physical. That's funny. We've got to get the drive out of the safe. Here you go. Yeah. Thank you for the follow. All right, let's run that again. All right, now we're getting 1.5, 1.5 on 675. Where's 675? Seriously? At least your parents tried. when they realized you know how to open the case and short two pins to make the computer go at age 8, they just gave up. Yeah, the whole phone thing disappear. That's good too. Like if we want date night, we'll like retreat and watch a movie. Sure, we'll toss an iPad at a kid. All right, but now we're getting some like obscenely large value for this. Did it go into the right space at least? 1.5 instead of 0.83. Height, still wrong. Why is this so hard? Because half height is a positive value. All right, let's just brute force this. Half height and vert.y. Width we don't have to worry about. Those are all positive. Hey, Tamatutu. Yes, we are still working on moving the glow into the UI. We are. Welcome. Happy Saturday. Yeah, good things are worth it, right? You know. Actually, I'm running low on liquids. I see. Why is the vert.y negative 20? Why is that negative 20? Isn't our box 10 tall? How does it get to negative 20? See, the center is negative 5. It's another test blunder. Yes, width and width. Okay, no wonder. That's the wrong one. We're up here now. We have height. Okay, let's make sure that we have these. That's width. That's correct. Height. Oh, happy Saturday. Yes, yes. Plan on getting Starlink off the lawn today. Got a little building mount thing. I'm gonna try to put it up on top of a building. Got a pole mount. All right. Yeah. So apparently my test was wrong. Let's see. Let's see how it likes this now. Oh, lovely. Okay. That's that's in the right ballpark. Half height, good. Can we not do these at the same time? We just want to test this one. So just test one. Okay, there we go. They're yelling. Vertex y is negative 10, which is correct because this is the bottom right corner. And to bring it up to speed, we're working on a rectangle that has a height of 10 and a width of 20. And so that means that this down here is actually negative 20. Oh, no, I did that wrong again. This is positive 20, comma, negative 10. There we go. So we're actually writing a little test for this point here, making sure the UV is correct for it. All right, so vertical-wise, -10. That's good. Height, h is -5. Why is h -5? That should just be 5. I moved the marker. Okay. So we're in here, quadrant 2. Just verify, yes, quadrant 2, 609. 609, yes. Okay. This should be the opposite way. The binary expression should be that minus that. Okay. Oh, goodness. This has been a little fun puzzle. It's definitely been challenging for mornings, but it's been good. All right, now we're uh, yeah, epsilon. Come on. Really? I don't really want to have to use the approximately stuff, but we will if we have to. All right, if this gets close to passing, we'll test it out in the UI. Like, why is this one 7 and the other one was 9? Like, I purposefully changed that because I thought they would have the same values, but I guess why would I change it because it wasn't breaking? And then why is the other one rounding up to 9? Just seems odd to me. Is it a larger value? Okay, that passes. Give it a build, then we'll throw it in the UI. Hey, thanks for the follow. Okay, that just finished. Godot. Oh, goodness. We haven't done many jokes today. We do bad jokes. Great bad jokes. A horse walks into a bar and says, "Oh no, I butchered it. Okay, never mind. Not doing that one. No, forget it. It's ruined." Okay, why isn't that black? The gradients are actually better this time. Top view. I'm a little surprised that these these don't actually go very far down to 0 there. Maybe we should check the 0 and the 1 point. Let's see, world environment here. Density, no. HDR threshold 1.0. Okay, take the glow off so we can just look at it. Is it stepping all the way up there? It's a neat thing about grayscale. There's only so many grays you can display, so you can see the transitions. All right. And then if we make the text longer, yeah, I would expect this to get down to 0. That should be, but there is no point there. There's actually nothing there. So it doesn't reach 0. Oh, fancy. I don't have vertices of point 0 and point 1. I don't. I think we might need to add them. But I'm using Lyon. And Lyon is doing the tessellating for me, so we'd have to inject some into the mesh. Can I force something in Lyon? Let's see. Let's go up to where we are generating that mesh. That's constraints. Is it in render? Inner curved rectangle. Yeah, we have path builder and we just ask it to generate some geometry for us. So maybe we could look at path builder and see what's on there in order to get some more points in there. Are we using curved rectangle for this one's cubic rounded rectangle and this one is curved rectangle? Okay. Let's go look at path builder. What type is path builder? It's a builder and that's from Lyon. What is it? Box.rs. I think it's actually from Lyon Path. And here you have builder. So yeah, begin and line 2, etc. Add point. So we could add a line segment. What's a path event? All right, let's do a line segment. I hope that this works. So we'll have to create a line segment, or we go to line 2 and end, or begin has a point, line 2 and then end. Let's do that at the end and see what happens. Or should we do that at the beginning? Okay, here, that's where we start. Okay, let's just toss it in here. begin point, and at this, what's our coordinate system for this? This is going to be some point. We go there, go to another point. No, this is a line two, and then we end. False. Don't close it. Does that mean it's open for when we do this? Uh, Maybe. All right, then we would do the same thing on the right side. So I think this is going to be 0 to 0, and here it's snowing. Oh, spring, you feisty. Mm. All right, point. Now it needs to be half the height. Yeah, border size. We actually need this. Hey, Modprog, how you doing? Good morning. So we need to place this in the middle. What's our Y middle? This is, it's going to be that divided by 2. All right, let's extract those instead. Let's call this outer width, and this outer height. All right, so now we have our Y middle, and this will be, well, first is X is easy because it's right there, and that's going to be outer Y middle. Now it goes to 0 plus the border size, border left. Then we have our Y middle there, and we'll have Y middle for each of these. And now on this side, this is going to be outer width, and this one will be outer width minus border right. All right, so we're just arbitrarily tossing some lines into the mesh. We'll see what that does. I've never tried this before. I'm not sure how it's going to go. We're gonna watch. All right. Border left, isn't there? Where is border left? Let's see, border origin. Oh, is it self? Self dot self dot border right? Is that something? It is, okay. Let's get Godot started, shutting down. All right, here we go. Let's see if we got our zeros and our ones. No, we didn't. Did it just say it didn't need them? Or what? Okay, we're gonna switch over into GLES 3 mode so we can see tessellations. Hopefully my computer doesn't cry, as it often does when we go into GLES 3 mode. I don't know why. I'm gonna try to keep an eye on that though. See there, already dropping frames. But we want wireframe, and can hide that. You can see that it's completely skipped any vertice in here. Same with this side. All right, so to get that in there then, wow. We can either choose some other points as the arbitrary 0 and 1, right? Like some value up in here, but that gets a little funny during the curve. It would be nice if we had some sharper corners. I think we might have to draw this ourselves, which we're currently doing, by the way. We are currently drawing that ourselves, which means that it should be in there. Because first what we do is we draw the outer border, and then we draw the inner border in the opposite direction to create a hole. The problem is that it didn't take into account these, because those loops were closed. So do we have to just insert them post facto? Why can't I draw it in the shader directly? The shader doesn't, well, so right now, what we're trying to do is the blue is our box, okay? And we want to set the value 0 here and the value 1. But there are no vertices there, so we cannot set those values in the UV to 0 and 1. Can't I draw it in the shader directly? Like the deformation of a circle? No, no, we can't. It's more sophisticated than that. Um, just to show a little bit. Let's hide that. Okay. So we can change individual radiuses here, along with the individual borders. And you can do this with a deformation of a circle. So I don't think you could. Oops, I zoomed. I meant to go top view. Is that still top view? Zoom out. There we go. Display normal. I mean, maybe you could, but it's a great question, Tommy. I'm not sure if you could do that. So if we increase the top here, right, how do we get this like that with these? So we're trying to just create a vertex here on the left, and then one also on the right. Because right now we're not getting any vertices in that region, and we would like them there. So either we modify the output of these and add it, pass in a big rectangle, and the shader only fill the border you want. Yeah, I don't want to do it that way though. Because I see what you're saying, right? You could have the rectangle, and then you have the settings, and you say, okay, well, only shade in this far, right? Same thing up here. That's an interesting idea. Hmm. All right, I'm gonna close Godot for a bit. Let's go to GLS 2 again. And I want to be able to use GLS 2 for this, which I could see it should be possible doing that with GLS 3. Yeah, you should be able to do all of that. So you could know where the outer corner is, where the inner corner is. I think you'd have to be doing cubic Bezier calculations to see if you're on the inside or the outside of a cubic Bezier curve in shader. Oh, that sounds rough. Seems like a lot more calculations than just doing it once here and then having the shader deal with it. Because you feel that now you have to draw 2 times approximately the same thing, but you're not a shader arbitrator. One in the CPU and one in the GPU. Yeah, I think well, it'll only happen once on the CPU and then on every frame in the GPU, right? So, I mean, doing less work is much faster than doing any work. If you do nothing, it's a lot faster than doing something. So if we do it once on the CPU and then the work on the shader is in the shader is a lot lighter, I think that's a good thing. And really all we have to do is add a couple of vertices here and then there to get this to recognize it. All right, I think my cubic Bezier code can be modified. Is it add cubic rounded rectangle? Because we have this in two places. We have add curved rectangle and add cubic rounded rectangle, and we could add these start and end points during the during this. We implement it for Path Builder. Where is it? Here. Self to add curved rectangle. Oh, that's for the cubic rounded one. This is for the curved rectangle. Yeah, and that's just calling this one. That's fine. So maybe halfway between the control points on the left and halfway between the control points on the right. And the control points for like this here, this curve, is actually going to be here for the inner one. And then for the outer one, it's actually very nearly, it's actually the same spot in this case. Yeah, it's right there. And then here, it's going to be here. It's a control point. But because the height gets pushed down, it's there. All right, so how do we do this here? What's going on? Curved rectangle, what is this? Is this our type? It is our type. It's just got a rectangle and corner sizes. Curved rectangle dot points and control points. We zip them together and we say Bezier, cubic Bezier to this after we do a self to begin and a self to line to. So maybe I think we can adjust it here and just have halfway points. We need to know what the halfway points are though. That I'm concerned that because we're putting these vectors or these points, they're not vectors, yeah, these points in this path that's along a line, it might just get omitted during the tessellation phase. So here's hoping. Huh? Curved rectangle creates points and control points. That's right. Yeah, a lot of stuff here. We're not going to begin at point 0 anymore. We're always going to line to point 0. But in some other cases, we will also need to line to, okay. Midpoints for UVs. Dash 2. Do you want it to work with any Bezier curve or only around a rectangle? Um, any, because here, in fact, our rounded rectangles are cubic Bezier curves. It provides a more accurate representation of a circle. And then this here is just a cubic Bezier, but with control points. And those midpoints are going to have to be, because our curve is from here out. We generally start here, then curve out. Which means we have to know, or it has to be calculated ahead of time, where the halfway point is between those. What do you mean it's easier to draw around a rectangle with some parameter than an arbitrary Bezier curve? Are you talking about like in a shader? Because I don't want to go that route. And in this case, we need something that can tessellate, and Lyon has cubic Bezier 2, which is useful to us, and it can tessellate the paths that you draw via these commands. So you have basically move to, line 2, curve 2, and you have, was it quadratic Bezier 2 and cubic Bezier 2. All right, we need to know what those points are. Let's come up with midpoints, and we'll just return an array of points. Mind points, midpoints. Hmm. Probably need to know the winding for this as well. And there will be 4 midpoints. You think it can be greatly simplified? Well, how would you draw a rounded corner without using a curve like a Bezier curve? What algorithm would you use? Let's see, we're gonna have 4 points there and 8 points for the others, which isn't going to zip well. I mean, maybe it's something that we do before passing it in. So we should have 8 of these, and then between the pairs, we create the 4. Trying to remember what these points represent. Top left 1, top left 2. Is that the beginning and the end? Top left, minus factor, plus factor. Yes, yes, that is. So it's the beginning of the curve and the end of the curve. Okay. We do these in chunks, which is why we use 0.0 and 0.1. Okay. Which means that we could do midpoints. But to do midpoints, we'd have to calculate, well, we could just use the points. That's going to be points. We'll just create an array. Array here. It'll be the, so the first one, if we go to where 0 should be, it would be 7 minus 0. Right? Let's just create a little function. We'll take a slice. Actually, this is a reference to an array. Can we do it that way? Then we'll give an array back. Oh, we have to name it. Left is going to be basically this here. So we got 0, 1, 2. So it'll be 2 minus 1. Wait, 0, 1, 2. 2 minus 1. I think I even said that. But I was thinking, my fingers tapped the other thing. All right. So 0, 1, 2, 3, 4. So 4 minus 3. You know what? What is it? 6 minus 5? Which means this is wrong. Well, 0 is the top left one, right? So 0 is going to be this one here. And 7 is going to be this one down here because there's 8 points. It just, it's not in the same pattern. It's because it's flipped, isn't it? So this should be like 0 minus 7, right? So now it's in the same pattern, but what are these values going to be? And we're going to return, let's say, just the array of all 4 of those. Reference there. And we should be able to chunk. So points chunk zipping with that. We'll take a look. Now let's do points and midpoints. There. Oh, let's call it a checkpoint. A little funny, just a little. Speaking of funny, we'll try this again. A horse walks into a bar. The bartender says, "Hey." The horse says, "Sure." Da-dun-ch. All right, all right. Toss an S on that. Oh, this is just midpoint because it's not chunked. Dad jokes. Yes, absolutely. How do you know when a joke is a dad joke? When it becomes apparent. We need iter on this. Actually, we could do an into iter because we're not going to use it ever again. Not like the points, or not like we're saving anything with that. Because those points are copy. They should be quick to copy. Expected type. I think it's here with this. Got it. Okay, so huh, that didn't work. These need to be paired up now. And the value? Are you borrowed? Or are you borrowed? We don't do anything else with those. Just pass the ownership in. We added a camera. Yes, that also means you missed the mustache. That's the mustache. How you doing? Keen Red. It's been a while. Just copy the point. Mismatched points. Oh, interesting. Yes. Subtracting those would be a vector. Can we into a point on that? Not much. Just had your birthday celebration. Oh, lovely. Happy birthday. Happy birthday. Nice. Can we into these? Because, yeah, those are vectors. I want them to be points. I expect you can't go from a. I really can't do that. What's such a bizarre night? A friend of yours got so drunk he's left in a jail. Oh dear. That's funny. So if we do F32, F32, we'll have to into that, right? Okay, I think we're going to do these into tuples here. There, now we have to fix the right-hand side because vector 2D can't do that. He went to some random house and thought it was at your house. They got so scared and called the cops. Oh, that's Finnish gun laws are different than in the US. How so? Curious. Oh, now we need runs on this. Everyone can own a gun, but it requires a proper reason to get. For example, hunting or competitions. Ours is just because we don't trust our government. And it's interesting because, yeah, well, we don't need to get into that. Yeah, you don't have anything more than a shotgun or a rifle. Well, that's right. Competitions or hunting, right? You typically don't go hunting with handguns. Although competitions, right? Handgun competitions are a thing. All right, did that build? Oh, it looks like it built. Let's just do this again. Let's run this. Let's see if we get those vertices. Handguns are very rare. Interesting. Oh, beautiful. We've made art. That is gorgeous. Look at that. That is fantastic. And this is why we printed out. Oh, we had too much DBG going on. Uh, this is the one I want. Midpoints. No. Here. All right. So points. So between these, we would have one at what, 7. This would actually be the same value, wouldn't it? Which is why they're way over there, because our midpoints are wrong. We only want, oh, we have to take into account our way top right, bottom left, and do the subtraction correctly. Okay, fine, we'll do it your way. So on the top, we're only subtracting the x's, and then we keep the y because the y on the top should be the same. That, comma, points. All right, that should be F32. So that one's good. It's these others that are not right now. Now on the right side, this is for the y. We keep the points for dot y. Oh, we need another y here. This should be x and this y. Plus, of course, every place has background checks and stuff. Yeah, we also have background checks and stuff. Six dot y. No sane reason to allow speeds over 130 kilometers per hour. All right, and the left side, the x is fixed. So point 0 dot x, and then we take the y here. Oops. Okay, that should be points now. Arguably, we don't even have to call into, because we could just call point here. I don't know. I've met quite a few gentlemen that they shouldn't even be drinking at 21. You know. Okay, and we need to clear off some of the other DBGs. Too many, too many, too many, too many. Gotta leave that one. All right, there we go. Let that bake. You were reckless when you were able to buy booze? Yeah. We do like home brewing and stuff too. We'll brew beer and wine occasionally, mead occasionally. Um, what other one? There's this other good one. What is it? It's from a flower. We actually brew a flower. Dandelion wine. We'll make dandelion wine. Okay, let's see if we. Well, it actually looks the same. Actually, there is a point in there. There's something in there. Ooh, I'm excited. Okay, that might have worked. Let's go to Gelius 3 just for a minute. If we get a little stuttering, it's because this is very CPU hungry on my box. Oh, it does have that there. Look at that. That's the point right there. Is that the midpoint between them? Not really, but it's closer. I wonder why it chose to put that there. Because it should have had one on each side. It looks like it's omitting them on the top, it's omitting them on the right, and on the bottom. But for some reason, it put that one in. All right, let's check on this. Path builder, provided methods. Well, that's a bummer. That's a bummer. Because the test loader is actually stripping it out. Kind of makes sense. Because we have the path builder. Let's see, what else can we do with the path builder? Um, builder with attributes. So we could include a custom attribute. I don't know if this is going to work though. Is only one vertice too much? Actually, we're missing 7. We want 7 more. We wanted more vertices. And it should actually be halfway between. So I think that our, yeah, we needed more. But the test later stripping it out is like, oh, you don't need anything. We'll just, fewer triangles. That's always better. Um, so I wonder, this builder with attributes, see, if we have attributes, does that, see, pass can store a fixed number of extra 32, F32 values per endpoint called custom attributes or interpolated attributes. Oh, I see, interpolated. That means it's going to interpolate them. I don't want them interpolated. Hmm. It would be nice if you could say, I must have this point. And we could have stored the distance as we went around with these attributes. Hmm. Interesting idea. But I wonder how it I wonder how it interpolates them though. Around or XY? Like what's the interpolation? All right, attributes, builder. Okay. I think our next step is actually just going to be inserting vertices. The problem though is that I don't think that these vertices are coming out in a predictable order. So the index is here. Okay, mesh array. They're being funny. Okay, we get the vertices, we get the indices. And the indices here, my daughter just comes up and so so we keep bees. All right, this is it's story time now. Um, we did have the hot tea moment. And she's been making this. Now you can't see it yet, but let me explain up to this point. And so my wife sews. Right? She sews all sorts of things, blankets, clothing, lots of clothing. Um, and um, I know, how does keeping bees and sewing clothing actually relate to each other? Well, this past year she became allergic to bee stings. Okay, so she's been going in for those shots and everything, and has like a bad day every month because she has to go in for her monthly bee sting. And well, And I don't know if it's like an homage to this or something, but if she made this. This is a brassiere with bees on them, and I don't know if you can see the bees. There, you can see little bees. They get little wings and stuff, right? And so she made this, and it looks just like normal clothing, right? Like, but earlier I told her that if she died due to bee sting, she was getting buried in that. So we'll see how it goes. All right. So yeah, clothing. She makes clothing. Let's see what else do we have here. We also like have goats and chickens, and one of our chickens is in recovery, lost both its feet, which was so sad. But it's doing much better now. We're taking care of it. I think I need four shapes for this, actually. I need four shapes. Basically, I need one quadrant, then the next one, then the next one, and then the following one in order to get the shapes closed to the right spot. And if we did that, we could break it into even smaller pieces. And we could have the curves, the top pieces, yeah, so the corners and the legs. And I think that's what we'll do. We'll break that down into corners and rectangles or segments. Hmm, that should work. That'll also give us the ability to do independent transforms on those. But I don't think we would. So let's do that tomorrow. We'll break that down. I gotta get my Starlink off the lawn. I'm gonna figure out who we're raiding today. Classy cat, JavaScript, TypeScript. Anybody have any suggestions? I don't know if we want to do JavaScript, TypeScript, and Rust. Although Svelte Rocket, yeah, Svelte and Rocket. Yeah, let's do that. So, thank you all for hanging out. It's good to have you here on this adventure. We'll get there. So until next time, y'all. Bye bye.